Hey everybody, Mr. Boatman here. This is another 2.6 Algebraic Methods video, and we are focusing on all the merit questions of the 2023 exam. If you're looking for more merit questions like this, I put all of the past NZQA ones, I put them all in one place for your convenience, so check out the link in the description if you want to access those. So let's get into question number 45. And we've got this quadratic fraction. We've been asked to write it in this form. So our job here, it's going to be a bit messy, but we're going to need to factorize the top and the bottom, split it up into two fractions, and then go for that. So I guess the first thing to do is jot down the question. So we've got 20x squared minus 22x plus 6, and all of that is over x squared minus 3x. So the top, not sure quite how to deal with it. It's definitely going to be the grouping method, but I can see they're all divisible by 2. So let's take out that 2 before I do anything else. So it's going to be 2 bracket 10x squared minus 11x plus 3. And that's going to be divided by, we can factorize the bottom, they've got an x in common. So it's going to be x bracket 5x minus 3. So I've got that there. This bit here in brackets up the top, that's going to be the annoying bit to factorize. So let's actually do this on the side over here by the question. So we've got 10x squared minus 11x plus 3. When you're factorizing with a coefficient, you've got to multiply the a and the c, or in this case, the 10 and the 3 together, right? So that's going to be 30. I now need to figure out, well, what multiplies to specifically positive 30 and adds to negative 11. And hopefully you're thinking the same as me. It's going to be what, negative 5, negative 6? Because they add to negative 11, multiply to positive 30. So I'm now going to split up this negative 11x into my negative 5x, negative 6x. So it's going to be 10x squared minus 5x minus 6 plus 3. I can now factorize the groups. There's group 1, there's group 2. Hence why it's called the grouping method. Factorizing the first group, they've got 5x in common, leaving me with 2x minus 1. The second group, well, they've got a minus 3 in common, leaving me with 2x. And I'm going to put in that math theory here, a common one, 2x minus or 2x plus 1. And I guess why this is a math error is a lot of people, when they take out the minus 3, that times that is still negative 3, but that's not what we've got here. So if we're taking out a minus 3, a negative times negative becomes positive. So that's why that negative 1 should actually be minus 1. And I like that because that gives me the same bracket. So it means I have done it right. I can now factorize that. So I've got the common bracket, 2x minus 1 goes there. My leftovers, 5x minus 3, form the second bracket. So 5x minus 3. So just a reminder, that's called the grouping method. If you're new to that, maybe your teacher taught you a different method and you like this one, and you want to know more about it, let me know and I can maybe find a video for you. So rearranging the top, so it's going to be 2 bracket 2x minus 1 bracket 5x minus 3. The bottom is unchanged. It's going to be x bracket 5x minus 3. And I'm liking what I see here because that common bracket 5x minus 3 can cancel each other out. So it's going to be 2 bracket 2x minus 1 over x. The top's a bit annoying in the factorized form, so let's expand that out. And now I can split this up into the fractions. So it's going to be 4x over x minus 2 over x, which is going to be, where these x's cancel, that's going to be 4. So it's going to be 4 minus 2 over x. So a and b, we now need to answer the question. A was equal to 4, wasn't it? And b was equal to minus 2. Right, so we're now on to question number 46. And this is a nice log question here, isn't it? So it's going to be 3 log x with a base of 64, and that there is going to be equal to 6. So I guess the first step here is we're going to go divide by 3 to both sides, aren't we? So we've got log x 64 is going to be equal to 2. I can now rearrange this so that x moves over here and pushes the 2 up. So it's going to be 64 is going to be equal to x squared. We're then going to move the square over to the other side. So the square root of 64 is equal to x. And I want to note a really common math error here. People are going to tell me x is equal to 8, which isn't quite right. Remember that because we're square root of 64, that's plus or minus square root of 64. So that means x1 could be 8, but x2, there's a second answer, that there could be negative 8. So we've got our two answers for x. So that's your achieve mark wrapped up. But there's a bit of a trick to this question. So whenever you get two answers for something, you should always check that they make sense given the context of the question or maybe the math that you're seeing. And in this case here, one of the answers doesn't make sense because x is the base of this question here, so the base of our log. And we know that x, or a log, can't have a negative base, which means this here is a false answer. So we're going to write false answer as x must be greater than 0 when x is the base of a log. So we needed to specifically identify and explain why that solution there was the wrong one and why 8 was the only solution to this question. So we're now on to question 47. Only 5 questions of this exam, so we're almost at the halfway mark. So we've got basically we've got an expression and we've been asked to make p in terms of x. So reminder what that means. So it means you need to come up with an equation where p is isolated by itself and it's equal to something, some kind of maths, and x is the only letter in there. So I guess let's get into that. The first thing I've noticed there is we're dealing with 5, 25, 125, and all of these are powers of 5. So what I'm going to do is, my first step, I'm going to change them all up. So we've got 5 to the power of 7x plus 6. I'm not going to change that, but that 25 I'm going to change to 5 squared. So that means 5 squared to the power of negative x. And that there will be equal to 125. I'm changing that to 5 cubed to the power of p. So I've got that sorted now. Now I can expand these brackets here. Just a reminder about your expanding rule. So for example, if you've got a squared to the power of 3, we multiply these together, right, to get a to the power of 6. We're going to do the same here with my expressions. So 5, 7x plus 6, unchanged. That's going to be over 5 to the power of negative 2x. So negative x times 2. And that there will be equal to 5 to the power of 3p. And again, that's 3 times p. Oh gosh. So we can now apply our quotient rule, our division rule. So we're just going to subtract the powers, and noting we're subtracting a negative, so this is going to become addition in this case. So it's going to be 5 to the power of 7x plus 6. That's going to become plus 2x, and that there is going to be equal to 5 to the power of 3p. The bases are in common, so they're going to cancel each other out. Simplify this at the same time. So that's going to become 9x plus 6 is equal to 3p. And now I can divide by 3 to both sides, can't I? To get rid of that there, get p by itself. So it's going to be 3p plus 2. So 3x plus 2 is going to be equal to p. And that's p in terms of x. Okay, so now on to question number 48 down there. So question number 48. Find the range of values for p. We can see p in our expression there, for which this graph, remember, that's just a positive parabola. So it's a positive parabola, does not cut the x-axis. So what this is really saying is, so you've got your x and your y-axis, and you're trying to find the values of p. It's a positive parabola. So for what values of p would it always be sitting above the x-axis? So it's not hitting that x-axis at all. So let's start by jotting down my question. So my function in terms of x is equal to 2x squared plus 8x plus p. So what this is trying to say is, so if it's not cutting the x-axis, we know that y is equal to 0 at that point there. So I'm going to take away my fx here, my y, and I'm going to set that to 0. So my parabola, when is it equal to 0? 2x squared plus 8x plus p. So this is really important because if this equation is true, based on the context of the question, we don't want it to hit 0 ever, that means there's going to be no solution to this question. So there'll be no solution when b squared minus 4ac is less than 0. So let's pull out our ABC. So we know a is equal to 2, b is equal to 8, and c is equal to p. So we're going to substitute all three of those into my discriminant, and then I'm going to solve for p, solve for my inequality, to check when this is going to be the case. So b squared is going to be 64, right? So that's going to be 64 minus 4 times 2 times p. When is that less than 0? So 64 minus 8p. When is that less than 0? So it's going to be 64. When is that going to be less than 8p? And we're going to go divide by 8, right? To both sides. Or divide by p. Divide by 8. So when is 8 going to be less than p? So we can flip that around as well, actually. So when is p going to be greater than 8? And then there will be our solution. So this quadratic, this parabola, it will sit above the x-axis for any value higher than 8. Now to question number 49, and I'm really liking the merit questions in this exam. I thought they were really easy. Hopefully you do too, and hopefully your exam ends up having ones the same. But basically we've got this quadratic down here, so systems of equation set up. We've got k here, so k's over there, and we've been asked to find the value of k. So this one here, we're just going to jot down my question for us. So we've got x squared plus 2x plus k. That there is over x squared plus 7x plus 10. And we've been asked to find out when that is equal to x minus 3 and then x plus 2. So I guess the first thing to note is I'm going to start by factorizing the bottom here. Oh gosh, I should note that I think I've written 2k there, but that there should be 2x. So that bottom there, leaving the top unfactorized, we'll just leave it blank actually altogether. That there would be x plus 2, x plus 5. And we can see we have an x plus 2 here. So what I'm thinking is, if we had x plus 5 here, that means this and this would have cancelled each other out, right? So if that was x plus 5 there, my x plus 3 must have been over here. X plus 3, so that would have cancelled out that, which is the same as this thing up here. So what I'm going to do here is I'm going to expand my numerator, which was going to come x squared minus 3x plus 5x minus 15. And that there is going to be over, I suppose the denominator is unchanged. We don't really care about the denominator here. And based on that, we can see our k value right there, right? Because this here would simplify to that. So it's going to be x squared minus 3. Oh gosh, it's going to be plus 2x, isn't it? Plus 2x minus 15. Over the denominator, again, I don't know why I'm writing this down, but it's unaffected. So this part here, compare it with the part up here, it's going to be the same, right? They both got an x squared, they both got a 2x, and we've been told that k is negative 15 there. So therefore, k is equal to negative 15. So that wraps up all the merit questions for this 2023 exam. These merit questions I thought were really, really nice, maybe the nicest ones I've seen. So hopefully, when the exam comes around, your ones will be this easy as well. If you're looking for more merit questions like this, check out the link in the description, and there'll be my bank of merit questions from all the past easy QA things there in one place for you.